my name is Megan Lenskold, and today I'll be going over my collab notebook for the final assignment of General Business 881. The purpose of this notebook is to understand and predict daily scooter rentals using linear regression. We're going to create a histogram for the total rentals. And so we'll see that the histogram shows how total rentals are distributed across all observations. So most values fall between 3,000 and 6,000, peaking at about 4,500. Next, we'll do a scatter plot. So for this, we are looking at registered and unregistered rentals as the X and Y axes. And we're going to differentiate between workday and weekday rentals by having weekends shaded in blue and workdays shaded in orange. So looking at this visualization, we can see that there is a pretty strong correlation between registered rentals and workdays. Now I'm going to use a swarm plot here to show the relationship between total rentals and season. So each dot here represents a day, and plotting them this way, you can easily see how the number of rentals tend to vary across the different seasons. I'm going to use a line plot to show the average number of daily rentals for each month. So the x-axis shows the months, and the y-axis shows the average rentals. I've also split the lines by year. We'll now run a pair plot to explore how total rentals relate to different weather indicators like temperature, humidity, and wind speed. So each scatter plot shows the relationship between rentals and one of those weather features. And for our last visualization, we're going to run a heat map to show the correlation between total rentals and the weather indicators that we had used in the last visualization. First, we'll find the correlation coefficient, and then we'll produce the heat map. Each square represents the strength and the direction of the relationship between the two variables. So these lighter colors indicate strong correlation. So now we're going to run our preparation for modeling. First, we'll want to separate out our X and Y variables. So for this, we'll continue our examination of the relationship between the total rentals and the temperature. So the temperature will be our x-axis and the total rentals will be our y. And then before training, we need to split our data into training and testing sets using test train split. So I'm keeping 25% of the data here for testing, which means the model will learn patterns from the 75% of the data, and then we'll evaluate how accurately it predicts the remaining 25. And so here, I'm creating a linear regression model and fitting it to my training data. So the fit function here is essentially where the model is going to actually learn. And so it figures out the line that best predicts total rentals based on the input feature. And lastly, for our preparation, we're going to find the y-intercept and the model coefficient. Finally, we are on to our last step. So now that the model is trained, we can use it to make predictions. So here I am asking the model to predict the total number of rentals for a day when the normalized temperature is 0.3. And so the model predicts that when the normalized temperature is 0.3, the expected number of total rentals is about 3,267. So now I'll use the model predict to the test set. And then lastly, I'm going to use metrics R2 score to compare the predicted rental values with the actual values from the test set. So the R squared score ranges from 0 to 1, where 1 means the model works perfectly and predicts it perfectly, and the values closer to 0 mean it doesn't explain much of the variation. So the higher the score, the better our model fits. So the R squared here is about 0.38, which means the model explains roughly 38% of the variation in total rentals based on the temperature. So the temperature alone captures part of the pattern, but there are other important factors here that influence rentals that the model doesn't account for.